Alright, so let's understand this question. It says that a body is moving circular motion at a uniform speed, so that is called uniform circular motion. So let us say that this is the circular path of the body, and let's say it starts from here at t equal to 0. So, for example, in half a time period it would reach here, and again in one time period it would be here, then again in two time periods it would be here, etc. So we have to find the displacement at 45 seconds. Now given to us that time period is equal to 20 seconds. So we have to find displacement after (45 seconds). Okay. So basically what we can understand is, comparing this and this, we can see that delta t is in fact equal to 2t plus t by 4. Okay. Basically, you can break 45 into 20 plus 20 plus 5. So that is t plus t plus t by 4. That way, okay. So after two time periods it would be here, and another quarter of a time period it would be here. So every time the particle reaches here, it is one extra quarter of a time period. So if this is t0, then this would be basically 5 seconds, 25 seconds, 45 seconds, etc. Okay. So basically at 45 seconds the body is here. So the displacement we are looking at now is this. Okay. So the magnitude of the displacement you can see is root 2, where r is this radius and this angle is 90. So just take that down. Moving on to the fifth question, it says that let's say this is the case. So what we can understand here is that from a certain point the body starts with a velocity of plus v at t equal to 0. Then it must be coming and returning back here to the same point. So when it returns, it has a velocity of minus v. Okay. And the time is t. So from that we have to find the acceleration. So acceleration is change in velocity upon change in time. So that is final velocity minus initial velocity upon time. So the final velocity is minus v, the initial velocity was plus v. So the magnitude of the acceleration, as you can see, is 2v by t. And of course, if you want to write the acceleration itself, that is minus 2. Right, so very simple question. Let's move on to the sixth one. The seventh question says that for a straight line motion, the relation between the position x and the time t is given by this, given by 2. So find the acceleration. That is, okay. So see here that acceleration in a straight line motion is defined as rate of change of velocity or second derivative of x with respect to t, or displacement with respect to t. So given that t is equal to x minus 1 to the power half, or t is equal to square root of x minus 1, see that x minus 1 is equal to t square. So x as a function of time is 1 plus t square. So velocity, which is dx by dt, is 2t, and acceleration, which is dv by dt, or second derivative of x, is 2. That becomes the solution here. Let's look at the 8th question next. It says what we have to find out in the question. Average acceleration would be much. That would be the solution. So the extremely simple 9th question, it says that a car moving along a straight line accelerates from a given speed to another speed in a certain amount of time. Find the average acceleration. So you take the initial speed as given as 4.1 meters per second. The final speed is 6.9 meters per second, and the time is 5 seconds. So the average acceleration is to be calculated. So average acceleration is let's look at the 10th question next. So basically in this question we assume that a body starts from rest, t equal to 0, starts from rest, it reaches somewhere here at a time t, and reaches somewhere here at a time 2t. Okay. So let's take this distance as x1 and this distance as x2. So we have to find x2 is to x1 in the question. Okay. Now you can see that the displacement is half a t square as a function of time. Therefore x1 is half a t square, and x1 plus x2 is the total displacement in a time of 2t. Okay, so that is 4 times x1. You can see that x2 is equal to 3x1. Quite an elementary question again. Let's take that down. We'll look at the 11th next. Displacement of a body is given as this much in meters. The acceleration at time t equal to 2 seconds. Okay. See, so the body has a uniform acceleration of 4. The 12th question says that a body starting from rest with a uniform acceleration. Okay. So you have to find the ratio of the distance traveled in the nth second to the distance traveled in n seconds. So let's look at this. Alright. So that means that the displacement in n seconds is half an square, and the displacement during the nth second itself is the displacement from n minus 1 to n seconds. Okay, so that is that much. Therefore it says that a bus accelerates uniformly from rest and acquires a velocity of 36 kilometers per hour in 10 seconds. So find out the acceleration. So let's look at the solution of this. equal to 0 and a is equal to a, which is constant, means that velocity as a function of time will be t. So v is equal to 36 kilometers per hour, or 36 into 5 by 18, or 10 meters per second at t equal to 10 seconds. Okay. So 10 is equal to a into 10, or the acceleration is 1 meter per second. So that becomes the solution of the 13th problem. Extremely easy. Have speeds of u and 4u. Find the ratio of their distances stopping. Okay, so let's understand this problem. It says that one particular car has a speed u at a certain time, and from that time onwards it starts braking, so it travels a certain distance before it stops. The second one is traveling at a comparative speed of 4u, and it brakes and it has to stop in a certain different distance. Now the cars are identical, so when they brake, their rate of deceleration will be same. So from that information we have to find the ratio of the distances traveled. So this is the first car. Traveling with the speed u. Now it starts decelerating at the rate e and comes to rest somewhere here. So this distance traveled is, let's say, s1. So we'll use the relation that this one. So 0 is equal to u square minus 2a s1. So that tells us that s1 is equal to u square by 2a. Okay. Now the second car is traveling at a comparative speed of 4u initially. So when it starts braking, it will travel a larger distance before it comes to rest. Let's say that distance is s2. So for the second car we'll write okay. So as you can see, s2 will become 16 times u square by 2a, or so that becomes the solution. So moving on to the next exercise. Okay, so the first question of exercise 2, it says that a body moving with uniform acceleration travels a distance of the displacement during the nth second is given by the formula from this we have to find initial velocity and acceleration. So as we've seen the formula before, displacement during the nth second is displacement from n minus 1 to n. So that works out to the formula comparing these two equations, you can see that u is equal to 9.8 and half a into 2n minus 1 is equal to 0.4n. Okay? In other words, we can say that, sorry, so you can see that the coefficient of n, it is a, and the constant term is u plus a by 2, sorry, u minus a by 2. Okay, so comparing this equation with this, you can see that that is 0.4n plus 9.8. Okay. Therefore, a is equal to 0.4. And u minus a by 2 is 9.8. So u is 9.8 plus a by 2, or 9.8 plus 0.2. So u is 10 meters per second. This is the solution again. Okay, next. Moving on to the 7th question. So it says that a particle is moving eastwards at 5 meters per second initially. In 10 seconds, it changes to 5 meters per second northwards. Average acceleration is equal to 100. So the initial velocity is 5 meters per second. Due east. Okay. And so this is at t equal to 0. And the final velocity is 5 meters per second due north at a time of 10 seconds. So we want to find out the average acceleration. So change in velocity upon time. So that is final velocity minus initial velocity upon time, right? So see that we can write that's a component algebra way of looking at it. So so the average acceleration and as far as direction goes, you can see that see that it is in the northwest direction. There's a train traveling at full speed. Now brakes are applied. So in the first minute it travels 8 kilometers and in the second minute it travels 3 kilometers. So initial speed of the train is out. So let's see. this is t equal to 0 when it starts decelerating. So at t equal to 1 minute, it has traveled a distance of 8 kilometers, continues to decelerate, and in a time of 2 minutes or a further 1 minute, it has traveled a further distance of 3 kilometers. Okay. So from this we have to find u. Okay. So you can see that and then for this interval, the total distance is 11 kilometers. Solving 1 and 2 will give us the value of u. So for example, the value of a from the first equation is how much? It is 8 minus u, whole thing multiplied by 2. And from the second equation, it is 11 minus 2u divided by 2. So apologies, this will be in kilometers per minute. Okay. So next, converting it to meters per second. Right, so that's solution of the 9th problem. right there. So now moving on to the 17th question. So this is what we do over here. So let's assume an initial velocity u and an acceleration a. So we can see that displacement is equal to ut plus half at square. So displacement after 2 seconds is 2u plus 2a, and displacement after 6 seconds, next 4 seconds it says, is 6u plus 18a. So from this we can also see that the displacement during the next 4 seconds, which we had seen, was 4u plus 16a. Now that is equal to 220 given, and displacement after 2 seconds, which is 2u plus 2a, is equal to 200. This is also. So now solving these two equations, we can find out the value of k. So for example, subtracting double of this, we'll get 16 minus 4, that is 12a, is 220 minus 400, which is minus 180. So we can see that the acceleration is minus of 30 by 2 or minus 15 meters per second square, and u is equal to 115 meters per second. Yeah. So from this we can see that velocity now as a function of time is 115 minus 15t. So velocity at 7 seconds is 115 minus 5. So that is 10 meters per second. That becomes the solution of this problem. So next we will look at exercise 3 after a short break. Okay, so we'll be starting with the solutions for level 3 exercise now, and starting with the 5th problem. So it says a car starting from rest. Welcome back. So we will be starting with the solutions of exercise 3 now. We'll start with the 5th question. It says that a car starting from rest accelerates at the rate of f through a distance x, then continues at a constant speed for time t, then decelerates at f by 2 to come to rest. If the total distance traveled is 15s, then you have to find the relation between s and t. Okay. So basically the 5th question says that from t equal to 0 to t equal to t, a car is moving with acceleration equal to plus a, then from t equal to t to some other time, it is moving with zero acceleration and uniform velocity. Okay. So this time we don't know. Okay. So this time is, let us say, t1. Okay. And this distance here is s. And then it travels for time t with a uniform speed. And then the third part of motion, T2, where T2 we don't know. And T1 is an unknown. But here it has a deceleration of minus acceleration of. Okay, yeah. So let's look at it again. So as per the statement of the problem, starting from rest, the car accelerates at the rate of f. So starting from rest, the car accelerates at the rate of f, traveling for a distance s. Okay. Thereafter, it travels for an interval of time t with uniform velocity, and thereafter it decelerates at f by 2 till it comes to rest. Okay. So now it says that the total distance it travels is 15s. Okay. So total distance is 15s. So we have to find the relation between S, F and T. So let us think of this as the first part of motion, this as the second part of motion, and this as the third part of motion. And let's get working on that next. All right. So for the first part, initial velocity is 0, acceleration is equal to plus f, and displacement is equal to s. Okay. So we can also see that s is equal to half at square. So from that we can say s is equal to half f t1 square. Okay. So from that we can say that t1 is 2s by f square root, and we can also use the relation that v is equal to at, that becomes ft1, so that becomes square root of 2fs. Let's say that velocity is 1 and this time is. Okay. So that now tells us that by the time it reaches here, it has a velocity of v1, which is square root of 2fs, and the time t1 is square root of 2s. So that tells us that the uniform velocity here is v1, which is square root of 2s. So that will help us understand the second interval. Okay. So now with these things in place, let us look at the second interval. So for the second interval, displacement should be equal to velocity into time. Okay. So let us say that the displacement is s2, and s2 is equal to the velocity into the time, which is t, and the velocity during this interval is square root of 2fs. The time is. Okay. So we've got s2 is equal to square root of 2fs into t. That's what we learned here. So this displacement now, s2, is square root of 2fs. So that is the conclusion that we are getting from the second part. Right? And from the third part, see that the final velocity is 0 here. So for the third part of motion, the initial velocity is this one. It is v1, which is square root of 2fs. Okay. The rate of deceleration is minus f by 2, that's given to us, and the final velocity is 0. So using the relation that v square is equal to u square plus 2as, we can see that 0 is equal to square root of 2fs whole square plus, or this will become minus 2 into f by 2 into s3, let's say. Okay. So this equation will help us find the value of s3. Right. So as we can see, okay, so s3 according to this is 2 times s. So what we are getting now is that this is 2 times s. Okay. This is given as s1. Okay. Right. So just take a moment there to absorb this information properly, right? Okay, so now we can see that total distance being s means that s1 plus s2 plus s3 is the total distance, which is 15s. So the displacement in the first interval was defined as s. The second interval we calculated it to be 2 times square root fs, which was the velocity, into the time interval, which was t. That's it. So s plus t into square root 2fs, right? Plus the displacement in the third interval, which came out to be 2s. So that is 15s. Now it's a case of solving this simple equation. So as you can see, t into square root of 2fs will become 15 minus 3, or 12s. Okay. You can square both the sides. So t square into 2fs will become 144s. Okay. Square. So we can see that t square f is equal to 72 times s. This is the relationship that we have. Okay. Or in other words, let's say that s is equal to ft square by 72. So that's another way to do it. Right, so that is question 5 for you. Now moving on to the next one, which will be the 12th problem. The 12th problem here says that a body or a particle is moving along a straight line, and its initial velocity is 200, what is it, centimeters per second? Yes, centimeters per second, and it has a deceleration. So we'll write the acceleration with a negative sign. So it has a deceleration of 10 centimeters per second square. So given this information, now the problem is asking its displacement will be 1500 centimeters. Options. Only once at t equal to 30 seconds. Only once at t equal to 10 seconds. twice at t equal to 10 and t equal to 30 seconds, and always doesn't make sense, so we'll say no. Okay. Right, so how do we understand this? So what's happening in this particular problem is that at t equal to 0, the body is starting off with an initial velocity like this, but with an acceleration like this, with a deceleration, as you can say. So what will happen as time progresses is that this body will have a velocity that is progressively less and less. So it's less than u. And at some particular point of time, v will become 0, and then it will come back like this, where v will become negative and come to this point. Okay. So now we have to just see that whether 1500 centimeters falls somewhere here or somewhere here or exactly here. Depending on that, we can see whether it will be having a displacement of 1500 centimeters from the initial point on multiple occasions, or basically 2 occasions, or on just 1 occasion. Okay. So using this information now, we can see that displacement as a function of time is ut plus half at square. So that is, in this case, 200t minus 5t square, because we have taken centimeters per second for velocity and centimeters per second square for acceleration. This displacement is in centimeters. Right? So for s equal to 1500 centimeters, the equation that we have is that 1500 is equal to 200t minus 5t square, or you can simplify this equation so that it will become t square minus 40t plus 300 is equal to 0. Okay. So now the point is that if it is having this displacement of 1500 centimeters on multiple occasions, that is on 2 particular points of time, this equation that we've got for the value of time for displacement being 1500 centimeters should give us 2 distinct routes. Okay. So there should be 2 particular instants of time when the displacement is 1500 centimeters. So it happens that way. Or the other thing is, in case it never reaches a displacement of 1500 centimeters because it turns back before reaching that much 1500, then this should not give us any real route, because it never reaches, there is no instant of time at all when it reaches 1500. And if in case 1500 is the displacement at the point of time when it turns back, that should then it should make that displacement only at a particular instant. It should not cross that point twice, in which case this will give us a single route. Okay. Now as you can see, solving this equation will give us 2 routes, and those routes are 10 and 30 seconds. You can see that sum of the roots is 40 and product of the roots is 300. So that's one simple way to just understand the answer, or you can factorize it or whatever. So you can see here, in fact, that what is happening is that, let's say this is a displacement of 1500 centimeters. So the body is once reaching that on its way to the maximum displacement, and that would be at t equal to 10 seconds, and also it's reaching that same displacement on its way back, and at that point of time the total time from the beginning must be 30 seconds. And indeed, therefore, it is making a displacement, or it has a displacement of 1500 centimeters twice, and they are 10 and 30 centimeters respectively, 10 and 30 seconds respectively. Okay. So just take a moment.